Hello students. So let's try to solve one more question from Jest 2021 examination, and this is obviously a set D, and the question is from a special theory of relativity, and this is from the part A, question number 6. So question is very interesting, and it is given that there is some frame Earth. With respect to Earth, a space shuttle is moving with velocity v. So velocity of a space shuttle with respect to Earth, and I can say this is my sigma. So this is Earth. So this is my sigma frame, and this is Earth. So Earth is moving with respect to, sorry, this space shuttle is moving with respect to Earth with velocity v. So velocity of s with respect to Earth is equal to v. And with respect to space shuttle, one craft is launched. So the craft has also velocity v with respect to space s. So velocity of craft with respect to s is also v, and this is, let's say, in I cap direction. And there is one probe fire from the craft by the pilot, and its velocity is also v. So this is, let's say, some probe p. So this is given that velocity of probe with respect to craft is v. This is also in I cap direction. So we have to find in this particular problem what is velocity of probe. So velocity of probe with respect to sigma or with respect to Earth. So we have to calculate it. It's a very interesting problem. Up to that, we have solved only 3-frame problem, but here we have actually 4-frame problem. But don't worry, every time we will create 3-frame and then we will go to the 4-frame. So what is our first duty? Our first duty is that we have to calculate the speed of craft with respect to Earth. So velocity of craft with respect to Earth, or sigma, I am just saying this is sigma, is given by v plus v 1 plus v square upon c square. I can assume this is my S frame, this is my S dash frame, and this is particle, and we can use this formula, and we have this particular thing. Now the whole problem is transformed into a very different way. So what will happen? The role of this S is vanish. So this problem is now reduced to, with respect to Earth, this particular C is moving, or craft is moving with velocity, and this value I can calculate, that is 2v 1 plus v square upon c square, and this value is equal to 2v 1 plus v square upon c square. So we have calculated, and now it is also given that the probe is also moving with respect to this c with velocity v. Now we have to calculate velocity of probe with respect to sigma is nothing v plus, we have 2v 1 plus v square upon c square by 1 plus v into 2v 1 plus v square upon c square. So when we will calculate this thing, then obviously you will check the option number C will be correct, and this is given by 3 plus v square upon c square and 1 plus 3 v square c square into v. This is very simple. You can take v common and you can take this as the denominator, and you can easily calculate the thing. So this is question number. So answer option is C. So obviously it's a very wonderful problem, and always we have learned the theory something like S and S dash, where S dash is moving with respect to V, and some point is moving with respect to S dash, and this is nothing but UX dash. So every time we will make the 3, we can calculate 3 once again, and again the role of this will vanish. First we have calculated Earth, space, and craft, and then we will go for Earth, craft, and probe, and you can easily calculate this particular thing. So it's a wonderful problem for practicing the Lorentz transformation and relative speed or relative velocity. Thank you.